Alright guys, welcome to another math tutorial video. This one all about the intersections of lines. Now this is a concept and a kind of little chapter or unit that I really enjoy. I'm not entirely sure why, other than the fact that it just makes such perfect sense generally. You know, you have your supplementary angles, your vertical angles, all that good stuff. You have these perfect relationships that you know always hold true. I don't know. I just enjoy it. So what I mean by an intersection of lines is whenever we have one line that does something like that and another line that does something like that. So they meet at this intersection. And by intersecting like this, they create four angles. Now, in my classes, I always label the angles 1, 2, 3, and 4. And what we're going to do in this video is figure out how each of these angles are related to each other. What do we know about each pair of them? Because each pair has some sort of relationship. So I always make this kind of a standard way of labeling each angle. Some students want to do 1, 2, 3, 4, or you know, something like that. But I generally try to get them to do this exact method so that we're all just kind of on the same page. So let's go ahead and talk about these angles. Now, in a previous video, we discussed supplementary angles. That's a big topic for this video and something really important to understand what we're going to be talking about here. A supplementary supplementary angles is essentially two or more angles that combine to form a 180-degree angle. 180-degree angle being a semicircle or a straight line. I had previously explained that if you start on a line, go through one angle, go through another, and end on the same line like we just did, it is a set of supplementary angles, like 1 and 2 are. So we have angles 1, and let me move this over, and angles 2. We know they're supplementary. Just like we can probably look at 3 and 4 here and figure, well, 3 started on that line, went around to 4, and 4 ended on that line. Angle 3 and angle 4 are supplementary, right? And then you got to think there's another line here as well. We can look at angles 2 and angles 3. We have angle 2 starting right here on this line, going into angle 3, coming down, ending on that line right there. Supplementary angles, angles 2 and angle 3. And lastly, we have line 4, or angle 4, not line 4, going right there, coming into angle 1, ending right there. Began on that line, ended on that line. So we have that next pair of supplementary angles as well, angles 4 and angle 1. Now, I always let my students kind of come up with these equations on their own, let them work it out. But if you think about it, if they're supplementary, it means these two angles combined equal 180 degrees. Let's write that as an equation. Now, whenever I hear combined, I think of adding. We're putting them together, right? So angle 1 plus angle 2, 3 and 4, 2 and 3, 4 and 1, all of them combine to form 180 degrees. Whenever I say to form 180 degrees, of course, that makes me think equals 180, right? So we have these four equations already, just with these couple of pairs of lines that tell us, hey, this is how each of these two angles are related to each other. This is the relationship they have. Now, right now, that's almost all the same. Let's try out a problem that just focuses on a relationship like this. Let's try out, let's say we have an intersection of lines here. Let's say this here is 125 degrees, and this is x. We want to find that. And what else we want to find is we'll call that y, and we'll call that z. Let's find all the other angles. So, let's go ahead and label them. This is angle 1, angle 2, angle 3, and angle 4. Now, I always just like to find x first. I mean, that makes sense, right? So, to find x, we know angle 1 and angle 2 is what we should be looking at. We'll find an equation that fits both of those angles, angle 1 and angle 2, so we know they equal 180. Let's set this up. Moving my camera. So we have angle 1 plus angle 2 equals 180. We know angle 1 here is represented by 125. I kind of look at these as variables, right? And then angle 2 here is represented by x equals 180. Simple algebra at this point. Subtract 125 from both sides, and we get x equals 55, right? So we know angle 2 here is 55 degrees. Now, based off what else we know on these equations, we can solve for these other two angles. Let's go ahead and solve for y. So y is going to be angle 3, and we'll use our newly found angle 2. Now, if you checked out our equations down there that we have written down, you'll know we have one that says angle 2 plus angle 3 equals 180. Now, angle 2 that we just found was x, but we found x equals 55. So we'll write 55 in its place, and angle 3 was y equals 180. Yet again, simple algebra. Just kind of moving some stuff around here, right? So subtract those 55s, and we get y equals 125. So we can fill that back in. 125. I'll save you the time on doing this last z problem here, and we'll find out that that z is also equal to 55 degrees. Now here's what this is going to tell us. You probably have noticed by this point that angle 1 and angle 3 are the exact same number, just like angles 2 and angle 4. Now, will this happen every time? The answer to that is absolutely it will. Whenever you have an intersection of two lines, the ones across from each other, the ones opposite of each other, will always be congruent, or the same, or identical. This is what we call vertical angles. Angles that are opposite each other are always the same. So now we have a new equation that we can write. We have new pairings, new definitions, right? So we have angle 1 and angle 3. And then we have angle 4 and angle 2. And we have to figure out how they're equal. Now, whenever I say these vertical angles, they're congruent, they're the same, they're identical, that just tells me an equal sign. If they're the same thing, we can say one equals each other, or one equals the other, right? So we now can add angle 1 equals angle 3 and angle 2 equals angle 4 into the mix with these other four equations. So these are the the 6 really basic important equations that you need to know for this intersection of angles. These 6 relationships between the different angles in an intersection of lines. I always tell my students, make sure you have these 6 memorized. As simple as it seems, just to know they're supplementary, just to know they're congruent, knowing these and knowing how to set up any given problem you're asked really makes a difference in making sure you get the right answer on any given problem you're given. So that's the basics of intersections of lines. Vertical angles, supplementary angles, all that good stuff. We'll go into some bigger examples in some future videos, but I just wanted to get the basics laid out right here. So thanks for watching. If you have any comments, concerns, or questions, feel free to leave them below or at my blog, mrmathclass.blogspot.com. Thanks for watching, and I will see you next time.